Anthropic, they quietly released a new model, and it's pulling off something that really shouldn't be possible.
Oh, yeah.
They call it Opus 5. It is somehow beating its much more expensive big brother Fable 5 on major benchmarks.
Which is pretty wild.
And the kicker is, it's doing this for exactly half the price.
It really is a fascinating moment for the industry. I mean, this release completely shakes up how we evaluate the cost of intelligence.
Welcome to the deep dive. Our mission today is unpacking Anthropic's Opus 5.
Right.
We are going to explore what it's actually built to do. We'll examine the hard benchmark numbers to see where it succeeds.
And where it breaks.
Exactly. We will test it against a genuinely messy, real-world dashboard project. And finally, we'll figure out if this is going to fundamentally change how you pay for AI tasks.
I am really looking forward to this conversation. The shift in how this model actually reasons through problems is remarkable.
So before we get lost in the benchmark scores, we need to understand the underlying foundation here. What is this model actually built to accomplish? We hear about new AI models every single week. What makes Opus 5 different from the rest of the pack?
Well, that is the right question to start with. Opus 5 is Anthropic's new high-end tier, but it is not meant to be a general-purpose chatbot. It is designed specifically for complex coding environments. It's built for deep, sustained reasoning and exceptionally long professional workflows.
So it's meant to stay focused on a single project for hours or even days.
Yeah, exactly. It's built to navigate across different files and applications seamlessly. The overarching goal here is autonomous decision-making.
Right.
You do not want to constantly hold its hand or correct its course every 5 minutes.
It has a massive capacity to support that, too. They gave it up to a 1 million token context window.
Which is huge.
It is. For those wondering, it's the amount of information the AI can remember at one time.
1 million tokens is a staggering amount of working memory. You can literally dump entire legacy code bases into it.
Wow.
Yeah, you can upload massive corporate document libraries. But the capacity alone isn't what makes it special. The really interesting mechanism here is something Anthropic calls adaptive thinking.
And it actually uses that by default, right? You don't have to toggle it on.
That is correct. Adaptive thinking means Opus 5 evaluates your prompt and decides on its own when a request requires deep reasoning.
Okay.
Older models just applied a flat level of processing to everything you ask them. Opus 5 dynamically scales its own compute power based on the complexity of the task in front of it.
It sounds kind of like driving a manual transmission car.
Oh, yeah.
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 For routine, simple prompts, it just cruises in high gear. It moves fast and uses very little energy. But when you give it a difficult, tangled task, it automatically downshifts. It applies significantly more torque and reasoning to push through the mud.
That is a brilliant way to conceptualize it. It is entirely about scaling effort to match the complexity.
Right.
If you ask it to format a simple email, it doesn't waste time pondering the meaning of life. It just formats the email. But if you ask it to debug a massive Python script, it slows down and engages that deeper reasoning engine.
Does adaptive thinking actually save time? Or is it just saving them server compute?
It genuinely optimizes both ends of the equation. It dynamically shifts computational resources where they're needed most. You get incredibly fast responses for the easy stuff, and you get deliberate, deep processing for the hard stuff. It balances the system load perfectly.
So it saves compute on easy tasks, buying time for the hard ones.
Precisely. It makes the entire architecture highly efficient for both the provider and the user.
So it sounds incredibly capable on paper.
It does.
But we both know that translating raw specs into actual utility is where most models stumble.
Oh, absolutely.
Let's look at how Opus 5 handles actual pressure testing in the benchmarks.
This is where the narrative gets really interesting. Reading benchmarks can be tricky.
Yeah.
If you only look at the absolute highest score, you miss the nuance of how the model is actually behaving.
You really have to look at the specific areas where its architecture provides an advantage.
Right. And for Opus 5, the clearest, most undeniable gains are in agentic coding and novel problem solving.
Okay.
Let's start with the coding side. It scores an impressive 43.3% on Frontier Bench v0.1.
Now, for context, Frontier Bench isn't just a multiple-choice test, right? It tests agent performance.
Yeah, it is a very practical test. It measures if a model can independently understand a complex coding task. The model has to use a command line terminal, run tests, read error logs, and keep working autonomously until the problem is actually solved.
Wow.
Hitting over 43% on that is a major milestone for autonomous agents.
What really caught my eye in these sources was the effort chart. tied to these results.
Oh, the effort chart is a crucial piece of the puzzle here.
The chart tracks how the model performs as you give it more time and compute.
Right.
It shows Opus 5 improves very quickly as effort increases, but its absolute best result doesn't actually come from the most expensive maximum effort run.
No, it doesn't.
You don't need max effort for top coding results.
That is such a vital detail for developers to understand. It means you can balance quality and budget effectively.
Yeah.
You do not have to burn maximum compute to get a fantastic result. Sometimes giving a model too much compute actually causes it to overthink and get stuck in logic loops.
That makes a lot of sense.
We see this exact same efficiency on Cursor Bench, too. It hits around 70% at its highest tested level, but it stays highly competitive at lower, much cheaper compute levels.
It also seems to perform incredibly well when the path forward is not obvious.
Yes, this brings us to reasoning and knowledge work. It scores 30.2% on ARC-AGI-3.
Which is a notoriously brutal test.
It really is.
Yeah.
The ARC-AGI test forces the model to explore completely unfamiliar logic puzzles.
Right.
It cannot rely on patterns it memorized during training. It has to learn from immediate feedback, figure out the underlying rules on the fly, and apply them.
That adaptability is critical for long-term research and planning. I mean, I still wrestle with prompt drift myself, where the AI just loses the plot halfway through a project.
We all do. It is one of the most frustrating aspects of working with AI. You get 20 prompts deep, and suddenly it forgets the original goal entirely.
Exactly.
But Opus 5 handles that sustained, continuous adaptation much better. However, we should be clear here, it does not win everywhere.
Right. The sources highlight that it falls behind in a few very specific areas.
It trails older models in deep SWE. And more importantly, it really struggles with legal work, health tasks, and a benchmark called Humanity's Last Exam.
At least when it doesn't have access to external tools.
Right, and for context, Humanity's Last Exam is a test made up of questions so obscure and difficult that top human experts struggle to answer them.
Why does it specifically struggle with things like legal and health tasks?
Well, those particular fields require rigid, exact, memorized domain knowledge. Opus 5 is fundamentally built for fluid reasoning and adaptation.
I see.
It is not built for rote memorization of thousands of specific legal codes or complex medical statutes.
It lacks the specialized memorization needed for rigid fields like medicine and law.
Spot on. It is an active problem solver. It is not a static medical textbook.
Benchmarks are incredibly sterile environments, though. They rarely reflect the chaos of everyday work.
Oh, for sure.
To really see if Opus 5 avoids that prompt drift you mentioned, let's throw a genuinely messy, real-world problem at it.
I love this part of the sources.
Yeah.
Let's look at the dashboard challenge. This is a brilliant test of its actual practical utility.
The test required the AI to build a working subscription health dashboard.
Right.
But the massive catch here is that the underlying data was provided as a raw, broken CSV file.
Calling it broken is almost an understatement.
Yeah.
The data was an absolute mess.
It had missing values scattered throughout. It had duplicate customer records. The date formats were completely mixed up across different columns.
It was a disaster.
It had monthly plans, annual plans, and canceled accounts all jumbled together in one list.
Which is honestly a standard Tuesday for any human data analyst.
Exactly. It's the reality of corporate data. Along with this messy file, they also included a rough hand-drawn sketch of the desired dashboard and a very short brand guide containing specific fonts and hex colors.
And the prompt itself was incredibly demanding. It asked Opus 5 to act simultaneously as a senior product engineer, a data analyst, and a UX reviewer.
Wow.
Yeah, it had to audit the CSV first. It had to apply specific, complex business rules for calculating revenue and churn, and then it had to build the entire working dashboard from scratch.
It also had to recalculate every single KPI and independently test the interactive elements before finalizing the output.
Right.
The result they got here is genuinely staggering. Opus 5 actually paused and checked the raw data before it took any action.
That right there is the agentic behavior we were talking about earlier. It didn't just blindly start writing code.
It found the mixed date formats and standardized them, and here's the kicker.
Okay.
It found 3 records that were completely contradictory, and it logically excluded those 3 unclear records from its calculations.
Whoa, imagine it just silently catching those 3 bad records and leaving a QA note instead of crashing the whole dashboard.
Yeah.
That level of autonomy is incredible.
Or even worse, silently hallucinating fake data just to make the math work out perfectly.
Which is exactly what older models do all the time.
Right.
They're fundamentally people pleasers. They just want to give you a finished chart, even if they have to fake the underlying numbers to do it.
Exactly.
Opus 5 actually paused, reasoned critically about the bad data, and systematically excluded it based on logic. That is a massive behavioral shift.
The final output was incredibly polished, too. It built clean, interactive charts. It generated a searchable customer risk table based on the data. It even included anomaly warnings for future data sets.
And the final KPIs were absolutely spot on.
Monthly recurring revenue was correctly calculated at $9,450.
Yep.
It identified exactly 67 active customers. Customer churn was accurately pinned at 13.16%. Average revenue per user was $140.52.
It nailed the math perfectly.
They really did.
To top it all off, it autonomously tested the dashboard in a simulated browser environment and adjusted the responsive CSS for mobile layouts.
Is it essentially making product and business decisions here, not just writing code?
Absolutely. It is analyzing the underlying business logic. It is deciding exactly how to handle strange edge cases in the data based on your overarching rules.
Wow.
It is doing real, tangible analyst work.
Yes, it's acting like a junior analyst rather than just a code generator.
Exactly. A very fast, very thorough junior analyst that doesn't need to sleep.
We're going to take a short break here.
Sponsor placeholder.
And we're back. We just looked at one very impressive, highly controlled dashboard test. But does this behavior actually hold up when independent developers get their hands on it and try to push it to its limits? Let's look at the community on X.
Ah, the wild, wild west of AI testing.
Exactly.
This is where we see if the marketing claims actually survive contact with reality.
3 specific case studies from the community really stand out in the sources. First up, a company called Lovable tested Opus 5 extensively for app building.
They wanted to see if you could take a vague concept and turn it into a fully working deployable application. They didn't just want it to spit out isolated small code snippets.
Their internal testing showed a 22% improvement on difficult multi-step coding tasks compared to previous models.
22% is a massive generational jump in this space. That is the difference between a prototype and a production-ready app.
It achieved the highest finished app quality in all of their internal tests.
Yeah.
It successfully managed the user interface, the complex product logic, and the core backend features all at once.
Because of that million token context window, it can follow the full software building process carefully.
Right.
It remembers the database schema while it writes the front-end buttons.
Right.
It did not just abandon the project halfway through.
Right. The second case study gives us an independent, quantitative verification of that exact capability. Artificial Analysis tested its coding performance rigorously.
Right. They run the highly respected coding agent index. It's a very tough benchmark to gain.
They independently confirmed the high performance we saw in Anthropic's own benchmarks. Opus 5 sits right near the very top of their index across several different effort levels.
It proves the model is genuinely universally robust. It isn't just over-optimized to perform well on Anthropic's specific in-house testing data.
No.
It works in the wild.
The third example from X is perhaps the most surprising of all. It is about how we actually talk to the model. It's about a massive shift in prompting strategy.
Oh, the prompting shift.
Yeah.
This changes everything about how developers interact with the API.
Anthropic actually removed over 80% of Claude Code's internal system prompt for these newer models.
80%. They just went in and deleted the vast majority of the behavioral guardrails.
And there was absolutely no drop in code in quality or safety.
That goes against literally everything we have learned about prompting over the last 2 years.
Yeah.
We used to have to write these massive, convoluted system prompts just to keep the model from going completely off the rails.
It feels kind of like taking the training wheels off a bike.
Yeah, exactly.
You do not need to micromanage it with a massive, exhausting list of repeated rules and negative constraints anymore. You just give it a clear, concise goal and let it ride.
You give it useful context, you define a very specific output standard, and then you just step back and let it work. It is internally aligned well enough to infer the rest of the unwritten rules.
Does needing less prompting make it harder to control the final output?
Not if you define the ultimate goal well. It simply requires you to trust the model's internal logic more and focus your energy on strictly defining what a successful final output looks like.
Less prompting means trusting its logic, but you still need clear output standards.
Precisely. Tell it exactly what you want it to achieve, not exactly how to execute every single micro step along the way.
So it builds complex apps, it flawlessly cleans messy, broken data.
Yeah.
It needs significantly less micromanaging from developers. But the immediate question for any business owner is, what is this actually going to cost you?
The economics of AI. This is where Opus 5 really disrupts the current market dynamics.
Let's look at the raw API pricing first. It is $5 per $1 million input tokens, and it's $25 per $1 million output tokens.
Which, crucially, happens to be the exact same price as the older Opus 4.8 model.
Right.
They didn't raise the baseline price for the new reasoning capabilities.
But more importantly, it is exactly half the price of their premium model, Fable 5.
Half the price, yet it consistently beats Fable 5 on several key reasoning benchmarks. That is a wild value proposition.
You can access it right now through Claude, Claude Code, Claude Cowork, and directly through the API. But the big structural distinction the sources make here is between token price and costs per task.
This is a crucial concept for developers and businesses to grasp. Token price is a vanity metric.
Yeah.
Cost per task is what actually drains your budget.
Opus 5 is significantly cheaper overall, not just because of the competitive token price, but because it requires vastly fewer retries to get the right answer.
Right. It makes fewer unnecessary tool calls. It doesn't get caught in endless debugging loops.
Yeah.
It needs far less manual handholding and correction from the human developer.
I was thinking about this like buying cheap paint for a living room.
Oh, that's a good way to look at it.
Yeah, a cheaper, lower-tier AI model might cost less per token, but if you have to apply 5 coats of paint, if you have to run 5 separate retries just to get a vaguely acceptable result...
It is so much more expensive in the end.
Yeah.
You burn through your token budget, and you waste incredibly valuable human time managing the errors.
Exactly. You waste time, compute, and patience. Opus 5 is a premium one-coat paint.
It gets the complex logic right on the first or second attempt.
Yeah.
That drives the actual realized cost per task way, way down for enterprise users.
So who is this model actually built for? The sources make it clear that it is best utilized for complex software engineering, multi-step agentic workflows, and navigating massive tangled code bases.
Basically, heavy, sustained professional use.
Yeah.
If you are building autonomous coding agents or running deep, multi-day research automation pipelines, Opus 5 is exactly your tool.
And who is it not for?
Simple, everyday writing tasks, quick email summaries, basic trivia questions.
Right.
You absolutely do not need the heavy reasoning engine of Opus 5 for that. A faster, dramatically cheaper model is perfectly fine for routine text generation.
At half the price and with these capabilities, is Fable 5 basically obsolete for developers now?
I wouldn't say entirely obsolete. Fable 5 is still there for absolute hyper-specific edge case extremes where you need maximum scale.
Okay.
But Opus 5 absolutely takes over the daily heavy lifting for the vast majority of developers.
Not obsolete, but strictly reserved for tasks where Opus 5 completely hits a wall.
Right. Fable 5 is the glass you break in an absolute emergency. Opus 5 is the reliable tool you reach for all day, every day.
Let's bring this all together and look at the bigger picture. Opus 5 isn't just an incremental bump in sterile benchmark scores.
No, not at all.
Based on everything we've unpacked, it represents a real, tangible shift toward true reliability and economic value.
It is a massive step forward in autonomous agentic behavior. It changes how we trust these systems.
It acts much more like a competent partner. It has proven it can handle messy reality like that hopelessly broken CSV file, and it can navigate long, frustrating workflows without needing a human to constantly look over its shoulder.
And it does all of this incredible reasoning at an API price that makes it genuinely accessible for daily, intense professional use.
Yeah.
It is not just a research experiment anymore.
It successfully bridges the gap between high-end, complex reasoning and practical, everyday economics.
You know, there is one specific detail from that dashboard test that I really cannot stop thinking about.
What's that?
We just saw Opus 5 take a messy, historically broken CSV file, and it autonomously built a clean, accurate, interactive dashboard by patiently reasoning through the data errors.
Right.
It caught the bad data completely on its own without a human writing a single script to clean it first.
It acted exactly like a seasoned data analyst.
So if these models are getting this exceptionally good at navigating messy, human-formatted data completely on their own, what happens to the massive multi-billion-dollar industry built entirely around data cleaning and pipeline preparation?
That is a deeply fascinating question to leave you with. As these tools get smarter, the layers of translation we need between humans and computers are slowly disappearing. Thank you for joining us for this deep dive. We will see you next time.